Structure is invisible to the customers. Still, it is very important giving them a safe and controlled driving experience. So our target was to create a strong structure with the highest possible crash performance. As you can see here, key to delivering is a super strong and compact front end, combined with an enhanced backup structure. Both of them are based on the intense use of high-strength steel, and they are combining together in a multiple load pass body structure. On the screen you see now a CAE animation of the torsional stiffness. On the left-hand side, the prior focus, on the right-hand side, the new focus. The movements which you can see are, of course, exaggerated in order to be able to visualize them. But I think it's easy to pick up that the new focus is significantly stiffer. We have improved the torsional body rigidity by 20%, which gives you, of course, a better feeling of solidity when you drive the car. But equally, or maybe even more important, we've also increased local stiffnesses. Local stiffnesses at the suspension attachment points to the body structure. And here the stiffness has gone up to 50% in individual points. But we also wanted to make the car quieter and make it more refined. To achieve this, we have decided that we introduce an isolated rear subframe in combination with our short, long arm rear suspension. This is a feature which normally is only seen in vehicles a class above focus. On the picture on the top you see the total subframe, and then below that you see a close-up of one of these bushes, and you also get a feeling of the dimensions which have been required to make that bush work to achieve the level of improvement which we've been looking for. And then the bar chart on the left shows basically the improvement, the difference versus the outgoing model, but also the difference versus the competition. I think in order to really appreciate the difference which we have been able to achieve, you need to drive the car, and most of you will have the opportunity to do that later in the year. But we are convinced that the level of incremental refinement which we've been achieved will be really appreciated by our customers. So a key objective for us to reduce the cost of ownership by improving fuel economy and emissions. And in order to achieve that, we put a lot of effort into the optimization of the weight, maximizing the aerodynamic efficiency, reducing the parasitic losses of tires and brakes, and of course, a new lineup of more efficient powertrains. And we've made fundamental progress in all of these areas, and let's start with weight. On a like-for-like basis, we have been able to achieve up to 88 kilograms of weight reduction on a total vehicle level. This was only possible through paranoid attention to detail and the commitment of everybody on the team to make every single part as light as possible. The chart shows you the major contributors to achieve the 88 kilograms. But don't worry, I'm not planning to go through that in detail, but I'm going to take a couple of examples to show you what we have done and how we achieved this. So let's start with the body structure. The body structure has a significantly improved crash performance. At the same point in time, we've been able to reduce the weight of the body structure by 16 kilograms. This was mainly achieved by the use of ultra-high-strength steel and press-hardened steels, combined with state-of-the-art manufacturing technologies like the hydroformed shotgun, which you can see here. So it's a tube, and then it is formed into the final shape through water pressure. At the end of the day, we could only achieve what we have done here by the intensive use of CAE tools, making sure that we have the right material with the right gauge at the right place in the vehicle. But the team also paid a lot of attention to the detailed execution of the designs. And a good example is here on the screen, our new knuckle, which we call a bionic skeleton design. We've been able to achieve on on this part alone, a weight reduction of 1.8 kilogram, achieving equivalent stiffnesses versus the outgoing part. That was an enabler to reduce the overall weight of the chassis front corner module by 4.1 kilograms. And that is something you will really feel when you drive the car. That helps to improve the ride quality. Now, let's move on to aerodynamics. As you know, all of the manufacturers pay huge attention in the moment to aerodynamics to improve fuel economy. This chart here shows you some of the, let's say, more iconic vehicles which have influenced aerodynamics over time, starting with a very famous Rumpler Tropfenwagen from 1922, car which you see in every aerodynamic handbook. That car achieved at that point in time a CD value of 0.28. And everybody thought that is something you can't achieve. And all goes basically up to the Tesla Model S. And we know some cars can achieve real great aero results, but they look a little bit like a science project. So I think what we've been able to achieve here is an outstanding aerodynamic performance combined with a gorgeous, good-looking vehicle. Just to read out the numbers, the 5-door has a CD value of 0.273 and the 4-door is even better at 0.250. This was only possible by really delivering a good basic shape and integration of aerodynamic features into the design. And that is really an integral part of the delivery. There are features in the lamps, there are features here, they're all part of the design. And that was only possible by intense cooperation between the design team on one side and the aerodynamic team on the other side. A daily exchange, a proper working relation between those two teams. So now let me go into a couple of examples what we've done to improve the aerodynamic. One is our active Grille Shutter system, which has improved ducting and improved sealing, will be deployed on 100% of the vehicles. We also have a new great feature, which is the front air curtain, which you can see here. So how does it work? The front air curtain is available on all of the derivatives, independing of if it's an ST line or an active. So a feature like this here creates a stagnation pressure, a local stagnation pressure. The air curtain now allows a portion of the air to go through here. It's guided on the inside. It will then exit through the wheel arch. The remaining air which flows around the outside, those two air streams will then come together, helping us to reduce the stagnation pressure, but also the airflow around the wheel, and to make sure that the airflow around the wheel stays attached. We've also spent hours and hours in the wind tunnel to improve the airflow along the underbody. The main aim was to improve the smoothness of the shielding, but if you look to the picture, the entire underbody is basically completely shielded from the front to the rear. So we've introduced a new shielding for the fuel tank, we've introduced shielding for the rear axle, and diffuser shield behind the rear axle. A good example for smart engineering is also the execution of the tunnel heat shields. They've been designed in a way that they also take over part of the aerodynamic function. Now let's move on to our powertrain lineup. First, our 1 liter EcoBoost engine. The 1 liter is available in 3 power levels and has been significantly upgraded for the new Focus. The all-new 1.5 liter 3-cylinder EcoBoost engine is a completely new engine, first introduced in the Fiesta ST and now also coming into the Focus. On Focus, we have 2 power versions of that 1.5 liter. The first one was 150 PS, the second one was 182 PS, featuring 270 Newton meters of overboost torque. Why did we select the 3-cylinder layout? 3-cylinder offers you lower weight, lower friction, and it also allows you the optimum displacement of 500 cc per cylinder. Both engines offer a rapid light-off catalyst, and we also have on both engines a new gasoline particulate filter. That filter allows us to reduce the emission of particulates by more than 90% versus the outgoing model. Now, there are two technology features which I want to talk to you about. Both of them are available on both engines, helping us to enhance our fuel economy, but also the power delivery. First one is, we are the only manufacturer in the moment who offers variable engine displacement or cylinder deactivation on a 3-cylinder engine. The engine management computer calculates whether the engine will use less fuel while running on 2 cylinders. If so, it shuts off cylinder 1 by deactivating the opening of the intake and exhaust valves. That significantly helps to improve the efficiency, mainly at lower loads. Changeover happens fully automatically and invisible to the customer. Also, both 3-cylinder engines offer a new radial axial turbocharger. As you can see here on the video on the right-hand side, the main difference is the geometry inside of the turbocharger housing. We have a curved inlet airflow, which helps to improve the efficiency of the interaction between the airflow and the turbine wheel. With that, the turbine wheel can be downsized, delivering the same output. A smaller wheel means a lower inertia, and lower inertia then means a faster response time. And the two graphs on the right-hand side basically show the effect of that. So the response time at lower speeds is improved by more than 20%. But we also offer the same level of torque at lower engine speeds. That both together results in a more relaxed but also a more responsive driving experience. Now let's move on to our EcoBlue diesels. These come as a 1.5 liter with 95 and with 120 PS, and as a 2 liter with 150 PS. Both of them, of course, feature the latest high-pressure common rail technology, which tunes the injection parameters exactly for best emission, fuel economy, and for NVH. The 2 liter also includes AdBlue technology to reduce NOx emissions. And for the first time in a Ford diesel engine, we are introducing a steel piston. The two reasons for a steel piston: A, it allows us to make the sides of the piston shorter, and secondly, the thermal expansion of a steel piston is smaller. Those two factors again help to reduce the friction and as such help improve fuel economy. These days, there's more and more demand for automatic transmissions. So we are very proud to introduce our all-new family of 8-speed automatic transmissions. Easily controlled by our beautiful new rotary gear shift dial. The transmissions offer adaptive shift scheduling and adaptive shift quality control, assessing your personal driving style, but also environmental conditions, and then adjusting the shifting accordingly. So, where are we on fuel economy? I think all of you know that this year the EU is moving from the NEDC, the New European Driving Cycle Calculation, to WLTP, the Worldwide Light Vehicle Testing Protocol. And the new focus is being certified under the new system. So it's difficult to make a like-for-like comparison to the outgoing model or to competition. But our internal testing shows that Focus generally delivers a 10% fuel economy improvement versus the outgoing model across the range. While the numbers are not yet fully finalized, the anticipated CO2 numbers for the 5-door manual are shown here on the screen. With that, I want to hand over to Guy. Guy is the man who was responsible to develop a big part which you will feel and experience when you drive the car. So, Ford Focus driving experience means it is intuitive, it is effortless, and it is always connected. But most of all, I hope and I'm convinced it is fun to drive. Over to Guy. Thank you very much.
Thank you, Helmut. So, hello everyone, my name is Guy Marteau, and together with my team I'm responsible for the driving dynamics of the new Focus. Let me start with the objective. So yesterday our Vice President of PD was quite clear, Joe Bakai. He said the objective, take the legacy of the current car and just go one step further. So it means improve on every sub-attribute of driving dynamics, steering, handling, ride and braking. Quite a task. So how could we do it? Very simply, it's a totally new car. So we could tackle every component from the body over suspension components, steering, braking, hardware and software. Everything new, attention to detail. But not only that, so we have an experienced team. It's the same team that did the current Focus, went on for the new Focus. And we have a very dedicated process to delivering driving dynamics. Just as an example of that process, the moment we had drivable prototypes, and that's quite some time ago, we had a monthly review, a monthly drive, not just on paper, drive, with our senior management, including up to our Vice President Joe Bakai, to assess the status and talk on where we are in the process. So that all to deliver this energetic driving experience which we have brought into the new car. So let me explain to you a little bit what the changes are of the new Focus versus the current one. Helmut already mentioned increased stiffness, obviously also interesting for us. I'll give you a little more words on that. Explanation of the suspension setups and settings. Novelties like the selectable drive modes and the continuously controlled damping. And then steering and braking, hardware and software explanations. So let me start with the first one, the increased stiffness. You've seen the numbers a couple of times now, so I won't repeat them. I just want to give you a small example of how we achieved these local stiffness or suspension point attachment improvements. This piece is actually a technology we are already using in the current Focus RS. It's a hybrid element. It's a plastic carrier. On top of that, you have a foam which expands and hardens under heat. We put it in the underbody in a cavity which is normally empty, and once it's fitted and installed and hardened, it adds stiffness to the structure. And in this case, there are two of these in every Focus, left side, right hand side. It adds 10% lateral rigidity. That's how we come up to these numbers. And all of those stiffnesses, they immediately translate into a better dynamics. Next one would be the suspension setups. Let's start with the well-known and celebrated SLA rear suspension, which is the suspension in the current Focus, short, long arm rear suspension. As Helmut mentioned, we now took it one step further. We did fit rubber isolation mount bushes between the subframe and the body. We know it has a great effect for NVH, but it helps vehicle dynamics as well. It improves comfort, it improves rolling plushness, and as we can tailor the bushes, the stiffness in different direction is different, we can keep the steering and handling and fun to drive. So it's really going a step further, and it would be a first within this segment. The SLA rear suspension is offered on the higher powertrain derivatives. The 1.5 EcoBoost and the 2-liter EcoBlue have it as a standard, as well as all Vignale active models and also the wagon. The wagon even has a unique version of this SLA due to the loading area requirements, which has to be very wide and flat. We repositioned the dampers more outwards to enable that loading area capacity. Obviously the suspension tuning for the wagon is also unique. But on top of the SLA rear suspension, we are now offering also a weight-efficient twist beam rear axle, but not just any twist beam rear axle. It's coming with the torque vectoring springs, which we introduced in the Fiesta ST. So this technology enables us to give agility to a twist beam vehicle and at the same time add stability to the system. So it's bringing the new focus with this kind of rear axle up to the level of where we are with the current SLA. Next, some models, they would have a unique tailoring of the suspension. The active is sitting 30 millimeters higher. In part, it's coming from suspension changes. We could have done that with just elongating the springs, but that's not an optimal solution. We did it with unique steering knuckles, the bionic knuckles, which Helmut discussed. They are unique for an active, which raises the vehicle by 20 millimeters. Further 10 millimeters are given by bigger wheels and tires. So in total, it adds up to 30 millimeters. The tuning of that vehicle is also unique to fit the active character. The other variant, the Focus ST line, which you see here, is obviously a more sporty derivative. So it sits 10 millimeters lower from a suspension point of view. It has unique springs, dampers and stabilizer bars settings. And on top of that, for the SLA variants of the ST line, the subframe bushes, they are stiffer than in a standard Focus. All to bring the energetic character even to a further extent for the ST line variant. Novelty in any Focus is now the drive modes. So Focus comes as a standard with 3 selectable drive modes. So besides normal, it would be Eco and Sport. So if you select one of those drive modes, it triggers changes into the throttle pedal mapping, the automatic transmission shift timing, the EPAS, so the steering feel, and the adaptive cruise control. On top of that, you can order as an option the continuously controlled damping system, or CCD system. That offers a clearly improved driving experience since it monitors the vehicle behavior continuously, and it can adapt the damper's forces to the situation. It comes with nice features like, for example, a pothole recognition. If the tire risks to fall into a big pothole, you risk damage to tire or suspension. The sensors can detect quickly falling tire and can stiffen up the damping and keep the tire up, and so it doesn't fall into the hole. Another cool extra or feature with this system is that it comes with different driving modes. So besides normal, you can also offer a more comfortable setting and at the same time a more sporty setting just by the click of a button. So you would have like 3 vehicles in one in a CCD system. So a vehicle with an optional CCD system wouldn't have like 3 driving modes, but the total increases up to 5 in total. And then, last but not least, steering and braking. Steering is probably the sub-attribute which is most important for us to get to our Ford driving dynamics DNA. Our steering has to be very responsive, very connected, very precise, and very intuitive. It doesn't come for free. So we spent a lot of time for the new weight-efficient EPAS system, the hardware, to optimize it, but also we have a new EPAS system, the software, and we've put in a lot of our in-house features. So our own experience from all the previous models is put into that, and one of those features, for example, torque steer compensations, but there are many others which enhance which clearly give at the end of the day the steering experience of a Focus. On a brake system level, there's a novelty of electric brake boost, which comes in a combination with specific driver assistance technology features, and the EBB system has clearly improved brake pressure builds up, hence better braking performance. The ESC system is also completely new. We are now using the Ford Stability Control System, which is basically an in-house developed system. It takes over all of the major ESC functionality by our own features, like for example the torque vectoring control, which we already know from the current vehicle and from other Ford products. All of the changes in brake system led up to an improvement of brake stopping distance in normal conditions, 100 kph, of up to 1 meter. So in a summary, these were all the changes we've made to the new car to develop the driving experience and bring it up to the next level and clearly deliver this kind of energetic driving experience. And so we believe it delivers a class-leading, fun-to-drive experience, which we think at the moment no competitor can match, but we'll let you judge that once you get to drive the vehicle.